Hi, hello everyone. This is our last video and last section in the tutorial. We will wrap up everything that happened so far, try to distill some big takeaways from this tutorial, and finally present a list of resources that I think that, or I believe that are very useful to continue your learning in this topic. But before we do that, let me just, come back to a few of the examples we have seen in the beginning of this talk and see also some additional examples of bias in the context of gender. This is based on a paper from last year, given a literature review about gender bias in NLP, in natural language processing. And here we can see a few tasks in NLP. Some of them we have already seen, like machine translation, speech recognition. We talked word embedding basically all this tutorial. Caption generation, taking an image and saying what there is in this image, and like generating text to this image. Sentiment analysis, like taking a text and saying whether it's got positive sentiment or negative sentiment. Language models, we saw some kind of variant of that with the text generation, with the GPT-2 model. So here we have a few examples. I mean, you can read them by your own. But, this is just to see one or two. Translating is a nurse, she's a doctor, to Hungarian and back to English. So from English to Hungarian and back to English, cause to the translation, she is a nurse and is a doctor. So we have here like stereotype association. And we lost something in the translation, right? Like this was the original sentence and we get totally or quite different sentence. The nice thing about this table, in this paper, and you can read about it more, they created some kind of dimension or aspects for the bias. So they had like four criteria or four categories. One about denigration, like a situation when we denigrate one group or a person by historical or cultural point of view. Stereotyping, when we capture some social stereotypes or enforcing or reinforcing social stereotype. Recognition is a question of accuracy or performance. Specific model is going to perform not equally for different group. And underrepresentation is question, for example, many times whether there was a bias in the data itself, or the data wasn't balanced and it was containing more example or more word association with one group to another. So, for example, in this machine translation case, so it was more about the stereotyping. We show here a specific stereotype, gender stereotype about profession, but also about recognition, because this was the original translation and we got another translation at the end. There is some information that got lost in this process of translation. Another example, for example, within speech recognition, we were talking about, black and white, like taken to these kind of groups, but it seems that it's also working with male voices better than female voices. This is in the context of gender. I can say that a few years ago when, like all this kind of ASR system, like automatic speech recognition system came up, for example, with Google, can you talk to your Android and, it will figure out what you're saying in searches in Google. I remember perhaps maybe, 6, 7, 8 years ago when I was using these kind of services with my Israeli accent in English. It didn't work so well. But finally, when I tried to imitate US American accent in English, and I won't do that, it sounds really terrible, the system could figure out way better what I'm saying, right? Like probably they didn't have so many examples in the training data set of Israeli accent English recordings and so forth. So this is another example of, what we call it representation issue. Sentiment analysis, for example, this is, capturing some sentiment, making more association of sentences with female than male, word embedding. I mean, we talk about the analogies that are not so good example or good method to evaluate words embedding, but we definitely saw tons of other, the the w-test, the clustering, the projection metric. We saw already other kind of metrics and way to assess a word embedding bias. So we basically already know this kind of thing. So this was, a bit overview, and this is also interesting paper. I think given a nice overview if you want, to go back and see a lot of concepts and ideas we have seen, and a bit more, like trying to formalize or create a framework to think about that. So this was some kind of, going back and looking about a bit more examples, and really like the path we did in this tutorial was really starting with a few examples, trying to understand why do we need word embedding, what are useful, like the idea of to represent text into numbers that in a way that a computer can work with. And we saw why, how it's give us a boost in the performance compared, from bag of words and other kind of techniques previously used. We've seen how this idea of how the structure, of word embedding is capturing some meaning, how it's capturing something that it's really useful. We get some kind of a vector space, geometric representation of word according to their context, they appear together or not. And then we jumped into exploring this idea of gender direction, she minus he, if you remember. And then, trying to ask how different words, specifically natural gender words, how they behave or distribute along this direction. And we've seen also a few examples how this kind of not evenly distribute or stereotypical distribution of words along this axis might introduce bias in downstream apps, like in other kind of apps. If you remember, we had this kind of toy example of the search engine, and as well as the coreference resolution system we've seen. We talked about how the kind of metric that tried to capture this notion of projection of neutral gender words can be tried to mitigate in like mathematical way, and we talked about slightly more intuitively. And then we ask ourselves, okay, have we really removed the bias? And there is this Hilagonen paper that ran different kind of experiments with the WIT score that based about more psychological testing and the clustering words. We saw that we still capture some gender information inside the word after removing, like allegedly removing the gender direction. So like talking about removing bias, mitigating bias, and so forth, it's a very, very tricky thing. Like it's really depends on how we measure bias, and it's definitely, especially in language, it's a very complex task that there is, we still don't know how to do it. And in fact, before in its foundation, I think it's the question what it's mean to remove the bias. So from this like very high level overview, I think we can go and talk about what, in my opinion, are the main takeaways from that. And you can see them here, the takeaways. And there are nothing new, like it's not like, like new takeaways. We basically stumbled across them in this whole tutorial. So the first, I identify four, like I think it should be short, and like easy to remember. So the first thing is about the downstream application. Another way to phrase it is like putting the system, the machine learning system you are working on, into human context. It's not about that, when we look about this word embedding, say, okay, let's say, assume we say this word embedding is biased. The first question is, so what? What are you going to do with this word embedding? So we can say, okay, I'm going to plug it with a system that, like in digital humanities, that try to capture historically biased, then okay, yeah, it's perfect that it's biased. We don't need to do anything about that. But if it's, for example, going to use for some search engine or a resume classifier or a sentiment analysis classifier system, that might be a big issue. The bias inside the word embedding might express itself in the downstream application. And when we are going to deploy this system into the word, it's going to cause harms to one group or another. And in this topic, I think it's really important to keep in mind the abstraction error. There is a link here to a really nice paper. I'm not going to dig in that so much, but I will just give specific example. One specific aspect of the abstraction error is like where we put the boundaries of the system. When we think about a machine learning system, right? Like we many times think about in an abstract sense. It's like, okay, it's a classifier, there is data, we train this classifier, and then we deploy it, and we get accuracy of 95%, and we are happy, right? But this classifier is going to be, or this system is going to be deployed in somewhere in the world, right? Like it's going to interact with real people. And for example, a classifier or a system that is deployed in the US or in Europe or in South America might have different consequences depending on the culture and the society is going to deploy it, and the kind of impact and potential good and also potential harms it might cause really depend on the context. Like even in the US, take one city on another. In Europe, Africa, it's really depend where we're going to deploy the system, what kind of impact it's going to make on people, and so forth. So the abstraction error is like saying something like that we might fall into the trap of seeing like 95 accuracy, there is a system working, we can deploy it, and it's all good, and we don't think about where is our boundaries of analysis or boundaries of consideration. And we need to understand that the system is going to interact with the society. It's going to interact with real people. So when we ask about question about bias, we need to reason about this kind of aspect. And this is the point where, just focusing on data science or machine learning is not enough. Like there is not, and as data scientists, I don't have enough knowledge to understand these full consequences. Like, it's really require legal aspect, political aspect, social aspects. As I mentioned before, the field of STS, science, technology studies, really trying to tackle this kind of issues. For example, I told you at the beginning that I was teaching a course about responsible AI, law, and society, and we had data science students and law students together. They worked on problems, together. They worked with case studies, they work with data, they will work with code. They need to really figure out things together. And big part of this idea to create this kind of mix of team is that each discipline, each student from one discipline really learn a lot from looking on the same issue, the same problem from the other discipline. And the very basic thing is because machine learning and data science are so powerful technology that really making tons of decision about people, just for narrowing down just for the core technical ability, even if we have the expert domain, this is not enough to analyze the impact. So we really need to think about the downstream application, how this kind of system we are developing is it going to be used. The second part is the question of measurements, and this is general thing, about it's coming across in multiple domains. You go to management. If you have one measurement you're choosing and you're going to optimize for that, it's sometimes narrowing your word. And I think a measurement like you're using in data science, is really asking what is a good system. When we are happy, when is the evaluation of this system is good. And we saw that when we defined the gender bias in terms of, average absolute projection on the gender direction, on the she minus he direction, we could come up with a mathematical way to remove this bias and make this measure equal to 0. And we were happy, we said, okay, we remove the gender bias. But when we narrowed ourselves to this specific measure that didn't capture the whole notion or the whole idea of what it's mean to have a gender bias, we missed, right? When we add the weight and the clustering, we figure out, okay, it seems that the issue of this bias in language, this gender bias in language, is way bigger than we thought, and we came up with new metrics. Now, I don't know if we have right now, a technique to mitigate or address or reduce the bias introduced by wheat and the clustering approaches. I don't know. I'm not sure whether it's possible while keeping the utility of the word embedding. But you see how the process of choosing the measure have the impact, right? Like, for example, if we talk about the automatic speech recognition, if you use an overall accuracy method or overall error rate, and you over all the population or over the data, maybe more precisely over all the data you have, you can think, okay, I'm getting, like very high performance, very low error rate. But when you split it into multiple groups, you see there is a use disparity, or one group is getting much lower accuracy and higher error rate. So the question of measures is not technical. It's really deeply conceptual. You basically ask yourself what is a good system. And going back for the previous point about the downstream application, putting into human context, for different applications, in different scenarios, in different situations, in different contexts, you might want to use different kind of measurements. So again, this is the point of measurements. So right now I'm not going to give a full overview how to think and how to what is the process to come out with measurements. You will have that in the resources sections. But my point is measurements is a big issue in that. The next point is I think this one is the most obvious than everything is the data. Bias many times comes from the data, not necessarily, but mostly, and we saw that in the word embedding, the issue of generation process, how the word created, this kind of newspaper articles and so forth. It was the generation process of this data. And this is many, there is a lot of also work around that if you're coming from NLP, but not only, how to build your corpus, which biases you might encode there, a question of, you choose what to take in your data and what out, a question, what are the features you are deciding to use. Sometimes you might choose the data according to what is the most accessible, but could be, suffering from some selection bias, you sampled just specific group of people that are not really representing the whole population that are going to use this system in real life, when you're going to deploy this kind of system. So again, the issue of data, and we talked about it. The last point, it's about question of impact. What is going to be the impact of the system on individuals, on groups, on society, humanity in general? And it's all these 4 points are intertwined with each other. So we also talked that before, but this is more taken into account, not only thinking about this impact, but what happened when your system is running for long term. It's not just something that it's not making one decision on a person, let's say multiple decisions on a person, or it's scaled up, or it is being automated. Think for example on a credit score. People are sometimes try to game it, right? How do I get a higher credit score? What should I do? And this is done, the credit score is calculated automatically. It's scaled up and it's running for the long term. So it brings a new kind of dynamics that you might not think, when you think about, okay, I'm deploying a system and given the training data I have, but the world is somehow, now changing, right? The distribution of the data in the world is changing from what you trained from. So, this is, from technical point of view, this is well-known problem in data science, question of domain adaptation, distribution, concept drift, and so forth. This is from the technical point of view, and there is approaches, methodologics, how to approach that. But it's also, when we think about a system, about the potential harms and ethical question about that, we need to consider this kind of, I like to think about it as lenses about how the impact on people might be. So this is really the biggest 4 takeaways. The summary right now is really in this sense was really high level, but for me, if you think about these 4 things, and next time when we flip for the last part of possible resources, if you have these four things in your mind, like I think you will be like better guided or being able to identify and read these kind of things and like to pay attention to the most important part. So again, think about a downstream application, basically to think how my system is going to be deployed and going to be used. Thinking about the measurements, how I'm going to measure or to assess whether it is a good system. Like this is like something, go through all the process of building a system, from the design, the formulating what we want to achieve, the development, of course, later in the monitoring of the system after it was deployed. Thinking about the data, this is a big theme, big pillar in, with the question of responsible AI and also without. And finally, thinking about the impact, how this system is going to interact and impact the society and people, groups, and so forth. So now I would like to go to a list of resources. I'm going to cover basically just 4 into depth, and later on are more like some kind of references for if you're interested specifically in word embedding or NLP. So this is from a handbook I hope to fully write one day about doing data science responsibly. But the part, it's in very early stages, but the part I'm keeping updated quite regularly is the part of resources. This is like a collection of specific resources about responsible AI. Like there is like starting with textbooks, tutorials, a list of conferences and workshop about this topic, kind of toolkits that are being used to question, working with machine learning models. Like this is like software packages, right? I think almost all of them, if not all, are in Python. Question of guidelines, checklists, frameworks, and so forth. There is tons of videos outside, but this is the one I like the most. Question about technology and society, going back from just the data science point of view, or like what we can bring from other kind of disciplines and so forth. And this is like a list, for example, of courses that are being taught all around, and some Kaggle competition that were in the last year in the context of responsible AI. So there are really a bunch of stuff here. Out of all these resources, I really picked up 4 that I think that are great. One is FATE tutorial, Fairness, Accountability, Transparency and Ethics from CVPR. It's like a computer vision conference, which I think is really good. It's like not hands-on and like not go to technical details as we did right now. But it's just going backward and give, I think, a really nice overview. It's like not hands-on tutorial. It's like like presenting a topic, like a tutorial in the academic sense. This is a really nice, if you're interested in bias in NLP. This is from the Fast AI course by Rachel Thomas. This is also a really nice talk. It also gives some kind of overview, slightly technical, but giving a lot of kind of examples, or all the way to to build a framework how to think about bias. And if you want a bit more kind of systematic resource about fairness and machine learning or bias, this is a great textbooks, but some of the leading researchers in the field. It is being written, it's like not fully completed, but it's available for everyone in the internet. And I would really recommend it. I think it's really well written and cover many important topics we talked about. I'm not going to go through the other resources, but this is like more kind of example. Some are blog posts, some additional work around word embeddings. In the last year, there was a bunch more of other stuff. A lot is happening in that. So this is like the one I found, I think, the most important, the most interesting. But I could miss some, so please just let me know if you found something interesting and I can update that to here. There are like And until 2019, there was just around, I think, dozen of papers around this topic of bias in word embedding and in NLP. The way it being looked now, or the kind of point of view, and there is now there is a boom also in the NLP community. So this is example to two conferences, one workshop, another part of a conference that were run I think 1 year ago, and it's hard to keep it up to date. There is tons of happening, just Google, but it's maybe two good starting point to look into. So this is all. Thank you so much for taking part in this tutorial. I hope you found it useful for you, and all this kind of concepts and point of view and important question to ask ourselves when we design a machine learning system that's going to interact and make an impact on people's life. We really touched in, I think, some of the most important aspect to consider, again, in the question of bias and fairness. And of course, there is tons more of additional aspects in responsible AI. Please reach me out in my website, through my email, or in the office hours. I would be happy to answer your questions and talk with you. So have a great JupyterCon conference, and yeah, see you around. Bye bye.